now that we're going to move away from graphing, we're going to talk about just the expressions themselves, not graphing them, but just multiplying, dividing them, adding them, subtracting them. Today we're basically going to focus on simplifying them, multiplying them, and dividing them. And they work just like any other fraction in that, first of all, you always have to have the simplified version. Like if I had 12 eighths, that wouldn't be the simplified version. What would you have to do to that?
Simplify it.
Divide by 4, top and bottom. 12 divided by 4 is 3. 8 divided by 4 is 2. So you divide out any common factors, right, to simplify it. Okay? Which is basically what this is saying. Like if I'm given AB over BC, they have B's in common, so they cancel out and leave AC. All right? The same thing works when you have binomial expressions, okay? Like 4 times x minus 1 over x minus 3 times x minus 1. Well, these have an x minus 1 in common, so I can divide them out and cancel them out.
So we're pretty much
Right. First, we're just going to reduce. Right, exactly. So I get 4 over x minus 3. Okay. So what you need to do when you have a rational expression is, first of all, factor it into its component parts, and then cancel any common factors. Okay? So in this one, x plus 4 is already factored. How about x squared minus 16? Can we factor that down? Exactly. X plus 4 and x minus 4. And then once we factor these out, then I look for any common factors. Do these have any common factors? X plus 4. So I can cancel the x plus 4's out, and all I'm left with is 1 over x minus 4. Okay? So that's simplifying. Why don't you take a second and simplify that? Tyler's going to explain how we did this one.
So you gotta factor this out, right? So it's basically just gonna be x minus 4, okay? Okay, and that equals that, and then you come down here, and you gotta factor this out, and it's just x plus 6, and then x minus 4. And then these 4's cancel out, and you're left with x minus 4 plus x, or divided by x plus 6.
Okay. Awesome. Now the question came up, can we write out both x minus 4's? Like since there's x minus 4, x minus 4, and x minus 4, can I just cancel them all out? And my response would be, it's kind of like 64 over 16. What goes into 64 and 16? 8. Okay? There are 2 8s in the top, but do I divide them both out when I do that? No. I end up with 8 over 2, right? There's 2 8s here, but I only divide out. There's only enough down the bottom for 1 8 to be divided out, so I divide out. Same thing here. There's only enough for x minus 4 to cancel one set out. This x minus 4 stays. Okay? All right, then to multiply rational expressions, you multiply just like you would a fraction. A over b times c over d is equal to ac times bd. Just multiply the numerators, multiply the denominators. Okay, multiply just straight across. Okay, and then we're going to simplify at the end. All right? Sometimes you'll have something like this. It's not really an expression because it's not binomials. It's just a good old multiplication of exponents and powers. So when I multiply powers, what I do with exponents? Add them, right. So I'm going to multiply numbers first. 5 times 27 is 135. X squared times x to the 5th is? Good. And then x or y cubed, and there's no y's here, so I just leave it y cubed. And then 3 times 15 is 45. X times x to the fourth is there. And y to the fourth times y. Y to the fifth. Okay, and then we just simplify. How many times does 135 and 45 have anything in common?
3,
3, 5, 15, and 45. Right, they have 45 in common. 45 goes into 135 3 times, and it goes into 45 once. Okay, how about x to the 7th divided by x to the 5th? Right, because when you divide powers, you subtract exponents. That's x squared. How about x to the 3rd divided by x to the 5th? Or, sorry, y to the 3rd divided by y to the 5th? Right, right, so it's just y squared on the bottom. Good. Okay? Now, when you multiply powers like this, the first thing you want to do is factor it all, and then write it out as one big multiplication problem and leave all the factored stuff alone so that you can cancel. All right? So first thing I want you to do is write all of this out as a factored multiplication problem. It's easier to watch me do it. Okay, so what do these have in common? 5x. So if I pull out a 5x, here I have left 4 and x. Okay? The bottom has an x in common, so I can pull x and an x minus 1. Here, x squared plus 3x minus 4 can factor into what? Right, x plus 4, x minus 1. And the bottom, x squared minus 16, we did that already, right? X plus 4, x minus 4. Okay, now I can go through and cancel out any common factors. So what can come out?
X minus 1.
X minus 1. Good. X plus 4. Yeah, because it's all being multiplied together.
Oh, okay.
So you can...
Is the x
and what
minus
else?
4 and 4 minus x different?
An x, right? Yeah, they are. 4 minus x and x minus 4. Like, what if x were 9? 4 minus 9 is negative 5, but 9 minus 4 is 5, right? So they don't work. But what would happen if I multiplied this by negative 1? This would become, if I multiply through by negative 1, negative 4 plus x. Isn't that what that is? Negative 4 plus x, or x minus 4. So if I multiply, so what I've got left so far is 5 times 4 minus x over x minus 4. Okay? But if I multiply through by a negative 1, I get 5 times negative 1 times x minus 4 over x minus 4. Now, these cancel.
Yeah, right.
Well, no, I'm basically factoring out a negative 1. It's not like I'm multiplying. I said it that way just because, but basically I'm factoring out a negative 1.
So it's basically negative 5 is your answer.
Right. So then these two cancel, and I get a negative 5. Okay. So that's why I don't have to do it on the top and the bottom, because I'm factoring it out. Okay. All right. Division works the same way, except you got to remember now when I taught this in middle school, I always taught, don't be chicken to divide, use KFC. KFC means keep the first term, so A over B, leave it as is. Flip the second one, so C over D becomes D over C. And then change the division sign to a multiplication sign. And then we've got a multiplication problem, just like these, and I work at the same way. Okay?
So I got to use something.
Keep, flip, change. Flip the second one, change it to multiplication. Okay? All right, so this is going to become, this is what I do. I would factor it all first, then do KFC, because you're going to be able to cancel some stuff out first. Like x squared minus 4x minus 21, what can that break down into? Right, x minus 7 and x plus 3, right? And 5x plus 15 becomes 5 times x plus 3, right? And then x squared plus 3x plus 70. Anybody? Right, x plus 10 and minus 7 over x plus 10, x minus 10. Okay? And then you can, just like simplifying fractions that we did at the beginning, you can cancel stuff here first to make it smaller so that when you do key flip change, you don't have so much to worry about. So the x plus 3's can cancel. No. X plus 10. Okay? So that leaves me x minus 7 over 5. Now I'm going to do the key flip change. So I kept the first one. I'm going to flip this one to be x minus 10 over x minus 7. And then I'm going to change the division to multiplication. Right.
That's going to screw me up so bad.
Okay. And then the x minus 7, like,
Take hold, you guys.
cancel.
Shut your freaking mouth.
And I get x minus 10 over 5. Now, can I divide this 10 and this 5?
Yeah.
No.
Okay.
No. You can never divide anything that's being separated by an addition or subtraction sign. Just like, remember back to when we had 12 over 8? I can't just subtract 8 from both sides, right? You have to get rid of one. And that's basically what you'd be doing here. You'd be taking away, you'd be subtracting instead of dividing or multiplying. So, you can't reduce this any farther. That's the best you can do, right? All right. And now, this one just looks a little bit different, but this is still a fraction. How would I write this as a fraction? Right, over 1. All right, so go ahead and try this. All right, so the first one factored out is 3x minus 2 and x plus 5, right?
Yep. What do you do for 6x squared?
Over 6x squared. Nothing, because we can't really factor it. And then 3x squared minus 2x, just the only thing that come out of there is just an x, right? So I get 3x minus 2. Then I got to do KFC. Keep, flip, change. So I keep the first one the same. I flip the second one. And then I change to multiplication. Can I cancel anything out? Yeah, the 3x minus 2's. Can I factor anything else out? Mm-mm. So my final answer is going to be x plus 5 over 6x cubed, right? Because we've got an x here and an x squared there. All right? Questions?